Hey everybody, it's Jeff, and here's what I did over the past few days for Workbench, where I stream my open source innovation work on Twitch. Tuesday, I started the potentially arduous task of generating a Go API for AppKit, the Apple framework for building apps. With the core bridge working to Objective-C, I want to now have native bindings for all the Apple APIs, and there are a lot of them. Luckily, as I mentioned a while back, every framework has a gigantic XML file describing every part of the API. They're actually in the framework bundles, and they're specifically for generating bindings or header files. So the first step would be to parse these into Go structures. These are quite big. AppKit is over 11,000 lines. So although it's not super well documented, Go has amazing support for parsing XML into structs. You just lay out the data types and map them using struct tags. And there is some documentation on the structure of these XML files that you can find out there. Basically, the man pages for this. Pretty much everything you need, I think. But I mostly also just referenced the actual files to figure things out. There is a twist. When the schema needs to talk about specific data types of any value or variable, they're encoded into these strange strings, and these are the worst ones. But usually they look more like. Here's an example, and it's even worse because of the XML encoding. Here's one. A lot of the time they're single letters or single characters, but they have some more complex ones, obviously for like structs and stuff like this. You're like, what the hell is this? So these are a weird like custom string encoding to talk about the types that are to talk about types, and they're kind of documented. Here's a mapping of the character code to what it means. It gets more complicated with things like pointers, bit fields, and of course compound types like structs and arrays. It doesn't really explain what the numbers were in those examples down here, which are specifically for methods of informal protocols. I had to kind of Google around to find out that apparently I can just kind of ignore these numbers. But there are still a few examples of characters that I just can't find documentation for. So I'm just going to kind of like defer those. So it took me a while to figure out how to parse these, right? Because there's a couple of, most of them are kind of single character, but then you have like these compound ones that have like their own internal structure and then their own nested definition of types. Some of them have names for fields. A pointer has like, so it wasn't like a trivial thing. I had to write a custom parser. I ended up using the Google Buff.io scanner, which I hadn't really used before. I used some of the built-in split functions, but it's basically a programmable tokenizer that you can use to relatively easily throw together a lexer. So after a bunch of experimentation, here's my split function that it uses, and then I can just use that with a scanner. And so this is kind of works enough, and I can kind of extend it as needed as I start doing stuff. And then that's makes it easier to then just parse a single type, which might then use that parser scanner to do nested types and stuff like that. But then I try and put all of this into a type info struct, which is basically a more friendly representation of that type data. The best part is I can have the XML parser automatically unmarshal into the type info type for the encoded field. So by just referring to that type info struct, there are interfaces that you can use that it will automatically use to unmarshal. These aren't, you can't find many examples of these. They aren't they don't have examples in the docs, but they are actually pretty simple to work with. This one is for specifically attributes. So at this point, we can actually run this. It works on tested on a couple of files, and it runs without error, and I get these giant structures, which it doesn't actually take long to parse them. It actually takes that long to just draw everything to the terminal. And there's definitely some stuff in there that's missing, but there are plenty of working ones. So at this point, there's plenty of holes, but it's enough to start generating some Go bindings and then go back and kind of fill the holes as necessary. Anyway, so I'll be doing that next week. Since this week I want to do some other stuff with the Go WASM UI framework prototype app. So that's it for now. Let me know if you have thoughts or questions in the comments. Subscribe if you'd like to start following along, or join me on Twitch Tuesdays and Thursdays. Thanks for watching.